We want to shut
first,
down.
First exit the software.
So first we exit the software here.
Then,
So there is a message here.
yeah,
Again, press OK.
yeah.
Press OK to exit.
And you don't, if you were just exiting the software just to maybe reset it or restart it, you wouldn't have to turn the instrument off, probably.
Okay.
You know, if you just wanted to work with the computer.
So now I closed it.
Yeah, now just shut down the computers like you normally would. And then would do the router also.
So should I do the same thing for the broker?
Yeah, it may be plugged into the same power as the microscope. Sometimes they're plugged in where
So this
if
is
you
a
turn the
broker.
main power off to the instrument, it may shut off the computers. But I don't think this one is. But it's always good when you restart to start the hardware first, then start the PCs.
Okay.
You know, just especially in the older vintages.
So now we
To
switch.
the right?
No, to the left is all just like starting the car. If you've got a car with a key switch.
So now it turned off. We didn't need to devacuum it.
No, you leave it under vacuum.
It's still under
It's under-
vacuum. You
okay,
always
so-
want to have it under vacuum before you turn it on. But what you're hearing now is the turbo pump slowing down, winding down. So it. But and then it's good to leave it like so. So then when you come back to
Okay.
So now again we turn it on.
Just start up.
So we just.
and just let it go back to on. And it'll automatically go into the vent, the pump down, the evac mode when we restart. And it takes a few minutes for the turbo pump to come up to speed before it would actually start trying to evacuate the chamber and do everything. But in case it got confused and things froze up or something and you called me back, this might be one of the procedures I would tell you to try to do: shut the PC off, shut the instrument off. Then you start the main part, and the microscope also has its own little microprocessor in it, so it's good to wait just a minute or so until all of it boots up before you start the PC up.
So give it like 3-5 minutes or a minute?
Yeah, a minute or so.
You should get your number too, in case you have your business card. Maybe we will stick your business card somewhere here.
Not for students.
So I will.
So if it was cold like for months, wait 5 or 10 minutes before you start the computer?
Or just a minute or so.
Oh, okay.
But it'll be 5 or 10 minutes before it would reach up to back ready.
Okay.
So I heard a few clicks, like the valves are starting. Go ahead and launch the software, which is SEM main menu.
Which one is S? This is SEM main menu.
Okay.
SEM main menu.
What's the Bruker one?
Is that Quantex or eSpirit?
Spirit?
And I would wait and let the
Esprit.
SEM software launch and then launch EDS, but I think they should communicate.
Should I open it now?
If you like.
So there is a password. Do we need login?
Or something. Yep.
Yeah. So I don't know if that's, I'm kind of wondering if that's part of the issue, if we're logging in and we're wrong and done that or something.
Yeah.
But I didn't see where turned it off and it was already ready.
Okay, let's say it was mothball, or not mothball, but we haven't used it for a couple of months. We'd probably turn it on and this would not say ready.
Yes, it would start by while it was the turbo pump was coming up to speed before it started actually pumping. It would say wait.
Okay.
Then when the turbo pump got up to speed and it was okay to start evacuating the chamber, it goes to pre-evac, and that's when you hear the pumps boom if it was venting. And then it gets to a certain level and it goes to evac, and that switches over to the turbo pump and will get you to high vacuum where you'll get to the ready state, and then you'll be able to turn on the electron beam.
Oh, there's different users.
Yeah, you can have a different login so it'll remember your specific conditions.
Okay.
If
So
you like.
now we can turn on the.
Well, let's don't turn it on yet because we want to look at the filament before it gets hot. So
How we know that the filament is hot enough?
if
Oh,
you've had
once
it
it's
on,
run.
it becomes hot.
Huh?
Because if anytime you use it, when you have to heat up the filament so that whole assembly will become hot. So
What is the indicator here? Then we can see.
there would
is
be
none.
it would only be you would have to know if the filament was.
If you'd used it that day, it's hot.
Oh, okay. So we have to wait like 10 minutes. Or
No, you probably want to wait. Do you want to do it before you use it?
Yeah, we will do it before we turn it on.
So how we know the filament is hot enough?
Well, usually it would after half an hour in the vacuum, it's probably cool enough to take out and make it handle. But there's also a tool like places that are really busy procedures to go through.
Which one? The maintenance?
Yeah. See where it says filament exchange?
Auto filament. Filament exchange.
Yes.
This one.
Yeah, go ahead and click
Click?
that one. Yes.
Okay.
So if you go ahead and play that and see if I thought there was some maybe
This
might
one?
have some on the video part on the window there.
Huh.
Yeah. I don't know if it shows anything.
It's
Click
not
vent,
active.
click vent the, or do we don't want to click that yet? Or what do we do next?
Well, what does it say?
Vent
Yeah, it
the
talks
electron.
about it being hot. Handle with clean gloves. So yeah, we can go to vent the electron or the gun chamber, which is going to be at the whole microscope.
This one?
No,
It'll
no.
be the same.
To your right, slightly. To your left, up, down.
Vent. Vent the electron
In the middle.
gun chamber.
That big
This
button.
one?
Yeah.
Yes. And it's going to be the same as pressing the button over here or pressing this button.
But that's so you can actually lift it up.
Yes.
Yeah.
So before it was saying ready. So what we are doing now?
Now we're venting, we're
Mhm.
emitting air into the chamber, so it's in the vent mode.
So then pressure
Ready
equalizes.
was when it was at a good enough vacuum level to use the beam.
Because we can change now the sample now after venting. But you said we don't know if the filament is hot or not, right? There
No,
is
we know
indicator.
it's cold. We know it's cold. There's no indicator for the heat.
Okay.
The only way you know it's hot is if you've used it recently.
Mhm.
And then, like I said, you can take this, just move this off. And then once it's, well, it may be quicker than.
Now you want to change the filament, or?
Yeah, I'm going to pull it out and show you how to do it
Mhm.
and what to look for. There also is some cleaning you can do
Okay.
that is going to build up some
Mhm.
residue.
What this probe is doing?
Hmm?
What is the function of this?
This is the objective aperture assembly. We'll
Mhm.
we'll go over that once we
Okay.
go through the beam alignment and stuff. Because after you change the filament, you're going to have to do a beam alignment.
Mhm.
But it's got 3 different holes. Like the number 3 is a larger hole, which if you were doing the X-ray analysis, you may want to use it because you get a more beam, so you get more X-rays. Number 2 and number 1 are smaller holes that are better for like a high mag imaging. The smallest one is number 1, might be the best for highest resolution.
What is it set on now?
It's set on number 2 now as a general purpose one that you could probably do X-ray and magnetic imaging
Okay.
and stuff.
And just to switch it, you would just turn.
Yes. Yeah, it's got a little steps. So
Mhm.
we'll go. It's probably not big enough to. So. And then you want to make sure this O-ring doesn't come out or fall out of its seat or something. So.
Oh, we had a bunch of those over there too.
So if it was hot, you could use this tool and just kind of tighten the screws.
Do we have replacement? How often do you replace the O-rings? Do we have replacements over here?
If nothing happens to it, it should be fine for long.
Okay.
How long. The only thing I would look at is before you close it back up, look at the surface and make sure there's no dust or like a hair across it or something like that.
Mhm.
So that's why we have this can of air here. It's always good to kind of and blow whatever little dust out.
Mhm.
But you can see on this down here is the anode. You can see it's got a little discolorization.
Oh,
What
yeah.
what is the
And
type
that's a
of
normal kind of
what is
residue from this.
what is the type of this filament?
It's tungsten.
Tungsten. Mhm.
So
And you said the lifetime is 40 hours.
30, 40 hours. Could be longer, could be less.
Mhm.
I'll try to show you how to maximize it. The easiest way to maximize it is
Okay.
but and this is the electron gun assembly, and this is the, as they call the Waynelt assembly
Mhm.
that houses the filament and stuff. And if we were going to clean this and reload it, I would go ahead and just close this to keep, like if any dust came out or stuff. But you can see it's kind of held in by 3 set screws,
Mhm.
and in the tip of the hole, you might be able to see the little small
So the
tip of the wire.
the electron beam comes from
yeah.
the center hole.
Yes, yeah, that little
Mhm.
piece of wire in there, and I'll pull the filament out. But if we were going to remove it, and just loosen the 3 set screws. And these filaments are pre-centered, so probably you would never have to adjust these screws,
Okay.
just the 3 that hold it in. And then this comes straight out.
Oh.
So you can see the little wire.
Okay. You said the worry was you break it.
Yes, it's very fragile.
Okay.
Mhm.
You
You
just
can see
aren't careful.
There's a little bit of contamination
Mhm.
there, residue. That this is normal for
Okay.
each one.
Do you
And-
clean that, or do you just let
Yes.
it build up? Okay.
You can clean it. It's recommended if you got the time to
Mhm.
clean it every time.
How do you clean it?
Well, you can clean it with a metal polish
Okay.
and just wipe it out, and then wipe off with a solvent like alcohol or acetone, and
Mhm.
sonicate it, and make sure there's no
Mhm.
residue and stuff. So you may be able, if you were in a hurry, to just put in another one,
Mhm.
but certainly after a couple of filaments, you definitely want to change it or clean it. There's also, like I was telling you about this micro 90 solution. It's I think an ammonia-based kind of
Mhm.
solvent that you could just basically put this in there in that solution
Mhm.
and let it sit for a while and sonicate it, and it'll come out clean. And then you
Okay.
just rinse it with water and maybe rinse it off with alcohol to get the water off.
Mhm.
Mhm.
It's the easiest way to do that. So, and I think we have three filaments left. There's probably some instructions in the book, and probably talks about polishing.
What are you taking out now?
The anode.
Yeah.
We have those screws here somewhere. I think I had them out.
These are?
Pushing some of this stuff out. But usually in our routine maintenance, like when I would come to overhaul it, I might pull out all the stuff in the middle to do it. But this is not very dirty.
Oh, it can get much worse.
Oh yeah.
Okay.
If you had a lot of filament time on it, this is.
What is the
pretty
material
clean.
of this one? Is it steel?
It may be stainless.
Yeah.
So, but I'm gonna throw it in there just since we're polishing it a little bit. So everything will be nice and shiny.
So
Also
this
we-
one automatically popped up, or? you
Yeah, I
did
think
clean?
every time you vent the chamber, that one pops up. But we're not concerned with that one at the moment. But clean this is we'll need some cotton swabs. Like if you have got Q-tips.
We
We
should
got
have-
Kim wipes.
Made these for cleaning. So this one should be enough. And probably one of these, this probably came with the instrument. So there's some metal polish in there.
Mm.
And I think this is a vacuum grease.
Oh.
So,
Okay.
and a lot of probably at the other lab there was probably a tube of polish stashed away somewhere, and probably a
yeah.
tube of vacuum grease somewhere.
Now that you say that, yes.
You know, if you get a big tube of polish and a
Yeah,
big
there
tube of
was a big
vacuum
tube.
grease, it lasts for years and years and years. Because typically you try to use as little of polish as you would need, but if you buy some of the micro 90 solution, it would be just as easy as that's what somebody had stashed this away for.
So now we are cleaning the holder of the tungsten or
Yes,
electron gun.
Yes. So we got that, and just a tiny bit of polish in here.
So what is that metal polish? Or what's that material?
It's like an abrasive.
Yeah, it's not. It's probably finer than it's really, really fine, like a diamond polish.
How we make sure there is no residual of that one on
We'll
this?
clean
That's
it.
when we
Oh.
put it in the
We'll sonicate
ultrasonic
it.
plater, cleaner and stuff. So, just a regular. These look like a little bamboo skewers that they're a little more sturdy than like an applicator stick, but the cotton doesn't stay on as good. So, I think I have a couple of cotton swabs. There's probably some cotton swabs in the other lab too.
Yep.
This polish is a little dry so basically I'm just polishing it out. And the longer if you skipped cleaning one time, the second time you clean is going to be much harder.
So
But if
every
you-
time you change the tungsten filament, you clean.
It's a good idea to do it, yes.
Okay.
But the hardest part is down inside the little concave area in the hole. So, to get down into it, that was like the point of this one's down to a point, just to get into the hole.
Floor too.
So
Although that was empty. Oh yeah, that's probably more than I
yeah,
need.
there's a lot.
I'm collecting my stash to bring up later to dispose of, because there of course is not a waste jug in here.
So we leave this. What they call this holder? What's the name?
This is called a Wehnelt cap. It's
Wehnelt cap.
Wehnelt.
German.
Wehnelt. Yeah, it would be vinyl.
Mm.
But I'm just trying to get as much of the polish out right now as I can, and I'll take another swab and dip it in the solvent and wipe it out, you know.
Yeah.
So, but I guess we might as well just go ahead. We'll go ahead and put a new one in and mark this one as used but okay, because you can see it's got contamination on it. That tells me it's got a few hours of usage on it. So we
But
don't really know.
if we needed one, it would still be
Yes.
available. Yeah.
Yeah, but I was going to ask my manager if they would, you know, if I think with your service contract you get a certain amount of parts,
Oh, okay.
but I don't know if you can order, if we can send you the filaments since they're like considered consumable things.
So now we had the head for tungsten filament or electron guns, and we put in acetone. We leave it in sonic bath for some time to make sure that they are clean enough.
Supposedly this will kind of, if you had any polish residue or something, sonicate this way.
For how long do you do the sanitation? 5 minutes? I never thought about cleaning by
Yeah, no, this
sonic,
is, yep.
because I put my nanoparticle for
Well,
dispersion.
if you get that time operating, it'll be pretty easy. Even like if you, a lot of the new stuff, all the auto functions work very well. So it's a lot of times people don't develop the skills to
Or the
to
understanding.
understand what.
Differences too, so
Yeah, I have a lot of conferences.
Yeah.
That's a good.
Not a very exciting part of it.
No, I don't remember. Like, this just brings back memories of cleaning stuff.
Something you got your students to do.
Yeah.
How many years have you worked for the
JEOL.
About 43.
40? Wow.
Have you always been in their optics, or?
Yes.
Okay. Definitely when we were getting the pictures of the skull,
Yeah.
it's like mine was okay. His was like,
No.
and then rinse it with water.
No, the final rinse, you want to have it in some solvent.
But would you do water and then solvent?
Only
or?
if I use a micro 90, because
Okay.
you already you kind of
Oh, super strength.
drying it so it doesn't leave a film. A lot of times this kind of stays in the Reynolds assembly, but this is basically a spacer that will kind of set your load current, sets how deep or far out the filament will come in the hole. The farther out of the hole, toward the edge of the hole it is, the more beam you'll get. So there's probably a couple of others in that blue box of this. So basically it goes under this screw is just basically a guide screw.
Okay.
But I think some of my set screws kind of maybe went in when it's sonicated. Yeah. So you have to kind of make sure you don't lose any screws when you're sonicating. So I want to make sure they're out of the way to put the filament in. But you can see maybe our set screw has come out a little bit, so it might be blocking putting the filament in.
Now we're putting the new filament. Interesting.
See, these is marked used. I don't know if these got changed like when we came to do a maintenance routine and just like we were going to do with that one. So these may be okay. We'll take a nice new one. So it's nice and clean looking. But it has a guide mark, and that's where that little guide pin screw
Okay.
is.
That's
So just
interesting.
carefully, line it up, and
That's a pure tungsten.
yes, and it'll be a really tight little fit. So it's got to go straight down on it, and you'll kind of hear it click into place like that. So now I need to tighten the 3 set screws back down.
Okay.
The little tip of the wire.
Yeah.
Hmm?
Oh yeah, I can see it now. Yep.
If you have a young eye, as you can see.
I got
Okay. Yes, I
I
can
got
see.
horrible eyes.
Me too. I have horrible eyes. I can see.
It should be right in the center
Yep,
of
it
the hole.
looks like a little
Yeah.
dot. Yep.
Yep. So that's how you can tell that it went in okay. It should be set in the center since it's a pre-centered filament. So I tighten the 3 set screws down so it's ready to go back in. But the way the electrons are pulled off of the tip of that filament is the accelerating voltage, whether if it's like 15,000 volts, is applied to this Wehnel cap.
Mm-hmm.
And like the other, whether it's ground or positive or whatever, but the opposite potential, say the anode is the other little piece is right down below it. So you've got that 15,000 volt potential from that tip, and then the filament is actually heated through these 2 posts. So the wire is heated, and that makes it easier for the electrons to be pulled off.
What is
By
the
that
material
potential.
of the anode?
It's just that stainless steel anode.
Oh, okay.
Okay.
So it's basically, if this is a negative potential, it's the positive,
Mm-hmm.
so just to pull the electrons off, because they're charged with a negative potential. So it's going,
And it creates like a bridge.
well, it's just pulling off a steady stream of the electrons, and that's why there's a hole in the anode, is they are accelerated down because they have that potential of 15,000 volts. They
Down the
keep
line.
going.
Yep.
And then the condenser lens, basically condenses it down
Yep.
together, and then the objective lens down at the bottom actually focuses it on the specimen.
So what is the material of objective lens?
Well, it's usually just a copper wire,
Okay.
typically. And there's some now that they can have a static kind of plates, electrostatic lens, but typically
So those
you would
wires.
think of a coil as a coil of wire.
So it
which
produces
direction?
some
It makes the
electromagnetic field.
It's the
and
magnetic
condense
field
them.
that shapes the beam.
Mhm.
Okay.
So, we've got a little stuff on the. Just close it back.
Is there any clamp or no? It's just an open close.
Vacuum is going to hold it, so
Yep.
you can follow the steps here, or we could just press vacuum. But I think we're down.
Should I close
to-
this one?
Yeah, just close it.
Now put vacuum.
Yeah, or you can see what the other says. It says mount the Wehnel assembly into the gun, blah blah blah. Yeah. So we just did that. So you could do either place.
What should I do now?
Evacuate.
Evacuate. Do you want to evacuate? Yes. Okay.
Yeah.
Checking to make sure your doors
check that
closed.
one.
This
too.
one?
Yeah. I'm just curious if it's going to give you another message. Go do a line or something. But since we installed a new filament, the first thing we're going to have to do is do the beam alignment. Usually, after I change the filament or something, it's usually a good idea to let it pump a little extra longer, because we've got all the solvent and stuff just to help it out, gas. Because we just cleaned it, so we don't want to start laying down more stuff immediately. The better the vacuum, the less stuff that it lays down. So if you let the vacuum get a little better, it'll stay a little cleaner initially. So if you needed a break or had something to do for a few minutes, now would be a good time.
Okay. Yeah. Maybe I go.
That would be the
Cost
high,
wise, what's the difference? I know you said this is really
maybe like double
okay.
this. And it'd be much more complicated operation, because it has it would have to have ultra high vacuum
Oh,
in,
yeah.
in the gun chamber, where this is just high vacuum.
Okay.
So this Wainwright cap has a guide pin also,
Okay.
and this has the guide pin here. So the two
Okay, I see that.
Yeah.
posts will go inside those
Okay.
contacts.
Yep.
And you feel it's kind of, this is like a little spring to hold it in a little bit.
And do you have to tie in screws now, or
Nope.
you're good?
It's,
Okay.
it's ready to go.
And then to take it off, it's just pull its pressure.
Yep. Yeah, that's this little spring. This is just a little spring that kind of holds it together and helps it make contact.
Is this a magnetic that are attached to it, or
No,
it's just
this is just a spring.
we need to screw it again here? No.
All finished. I'm gonna grab this piece. There's different types of sources, like the highest power source that is the brightest and can give you the highest resolution, which we'd probably need if you were trying to image like these nanotubes, or maybe even your really nanoparticles and whatever would be. It's called a field emission source, and instead of, it still has, you know, a potential that draws electrons off of it's typically, you could say, like a tungsten point, but it's a very sharp point instead of a wire. So it'll just pull the electrons off a very, very small area. So that helps make a more coherent, brighter beam instead of pulling it off of a large area of the wire. But it will apply a little heat. All things, and it did this. Now we'll go to filament adjustment. And this is the page where we were at before, and this shows the filament heating current,
Okay.
you know, that we were talking about, how you saturate the filament. But maybe for the first time, we can try to let it automatically align it. There's a very good chance that we can turn it on and it's going to be pretty well aligned because the filaments are pre-centered and stuff. So
full auto, it does everything. Semi-auto,
Yeah.
what do you have to adjust?
well, I'll show you. We'll go through the manual adjustment of everything first, and then we'll try the auto and see how it goes.
Okay.
Because I'm kind of thinking that, you know, since there's no real abnormalities and stuff that we put in the new filament, possibly the only difference in the alignment is going to be, you know, a little bit of adjustment with the tilt, just because of the position of the new filament.
Yeah.
Plus, the heating may be a little bit more, but I feel like probably when we turn it on, it's going to come back to like we left with the other one. So we'll try turning it on and see. Okay, so we got a little bit. Maybe it's a little less dim.
Oh, those are
The teeth.
the teeth. Yeah, okay.
Yeah.
Those are the teeth.
See, but it's a lot darker than
Yep.
probably like when we left it, and that's because with the new filament, it's probably needs a little more heat to generate the beam a little better. So basically, curve of a tungsten filament, that as you apply the heating current, and this would be the emission or the load current or the brightness of the beam, that as you slide this up, you know, you'll basically have no emission, and then you'll start to get some emission, and it'll come up, and you'll have a false peak, and it'll drop off, and then you'll have a second peak, and then if you keep applying more heat, you're saturated, so you're not going to get any more electrons.
Okay.
So if you leave this slider marker probably out in the orange in this area, you probably only get a few hours of filament lifetime. You know, but if you the goal is to kind of operate a little bit undersaturated, so you get the most brightness you can and the longest lifetime. And even if you ran a little bit lower, you know, you may get a lot longer lifetime. But you don't want to run on this false peak because it's not quite as stable. So this is where we kind of want the slider to be, and we'll judge this by looking at the brightness of the image.
Okay.
And we'll also do align the beam, shoot it down the hole in the column by using these adjustments. So the way I'll check to see if we have enough heating is I'm going to just gently slide the slider over to apply more heat. You can see I'm getting more emission there.
Ah.
See, but I know this is probably too hot. But so I'm pretty sure I'm in the saturated area. So briefly, while I'm in there, I'm going to just quickly see if I got the most beam coming down the column by making the brightest image with the gun tilt. You see it got a tiny bit brighter, so it was really close. And I'm getting a little more current because I think we were only like at 34 on the other one.
Mm-hmm.
But now I need to return this to a more undersaturated condition. So I'll just step on along until I see the brightness start to decrease. See?
Yep.
So you can see with the new filament, it's over farther this way, and that's just because the filament, the wire's thicker and it takes a little more heat. But after about half an hour, once it's heated up good, we'll need to recheck this because it's probably going to take a little less. So if you put in a new filament and you saturate it the first time and you never change this, you probably get a short lifetime.
Okay.
So during the course of operation or stuff, I always tell people that maybe when they're finishing the session or something to run this auto filament alignment, and that just automatically checks the position of this. So we've got it set like right here. We'll do the auto to see where it sets it, and it should try to set it a little bit undersaturated. So, and it also did an auto contrast. That's why it got brighter.
Oh, okay. Okay.
So, but I think it set it even a little farther undersaturated than I had it. So I'll check that by just increasing the heat. And you can see it's getting brighter.
Mm-hmm.
So we set it close to where we had it, but a little bit undersaturated. But as the filament ages, it takes less and less current, like the one we were at maybe was over here. So if you just, okay. So I would take and put it on one of the little round pumps or
Here?
stubs. Yeah.
Over there.
Yeah, you can use one of those.
Wait, did I put the tab? Did I put the sticky part on the right side? Are both sides sticky?
Yeah.
Okay.
One maybe is stickier than the other. Maybe.
Hope I did that right.
And then once you put it in there, you can tighten it with the set screw a little bit, just so it doesn't fall out
Like that. There is no set screw in this one. I don't think. Is I missing a set screw?
Yeah.
Oh, okay.
Keep going.
Oh,
It's a little more noisy, but I would just do the sliders till we have a maximum brightness. Then to adjust the shifts, I'm going to go to a larger spot size, like 70 or 80. The sample may not like it. There's a lot more beam. So, and at a larger spot size, I maximize the brightness with the shift. It's all pretty good. I'll go back to 40. And if you had to change the shift a lot, then you may go back and recheck the tilt. So this comes into account when you're doing the alignment.
So we don't need to adjust this
Well,
aperture?
we will
Yeah.
at some point. The easiest way to adjust it is like if you're at a low mag, you know, that if it was out of adjustment, you know, you see how if I turn it just a tiny bit, you know, we're losing the brightness, but you basically want to try to center that amount of brightness with these knobs. And that's a good course adjustment if you lose the beam or something. And also, like you said, this has like 3 is a larger beam. You see it's brighter, but maybe you get a less resolution. 2 and 1. But if you lose the beam and you think somebody has misadjusted this, you can like go to the 0 position where there's no aperture in it.
Okay.
That would tell you if you didn't have a beam and you moved it out to the 0 position, that would tell you for sure that this is misaligned. So I can go to 1, and if it's misadjusted, you kind of have to go, I would go like in between 1 or 2 or 3 at low mag and just try to move it until you see the brightness again. Like the way I kind of do that sometimes is like if I would kind of slide this back and forth and adjust this until I actually saw some brightness, and then you can finally do it. And that's a good course adjustment for that, but yeah, it's going in an angle, maybe the other.
I found it.
You know what, you're gonna have to like do both. I just wanted to
Okay.
hold it just fine.
Is there any reason? Nope. Yep.
And some of the other holders have both on them, the screws and the Allen set screw. You know, in that certain position and get where we got 22-degree tilt right now, that should clear that when you hit, when it goes to that position.
So what did you click there?
I clicked SNS capture.
It's
Then?
putting it up under that camera,
Mm-hmm.
and that just makes it far away, so it's easier to remove. And
So
you're gonna
after,
have to take
so
one.
in SNS, what did you click on?
Under stage, I clicked on SNS capture,
Okay,
and
so
that
you
brought
can
the whole
bring
thing
that
down.
up.
Okay, and now,
I can
yeah, you
event.
can go ahead and vent. But also, too, to take that picture, it moves it to the -10-degree tilt. So
Oh, okay.
we'll have to set that to 0, but you can wait till it vents. You'll see it when you open it. Click on the T and 0.
Neat. You gotta press the buttons.
Hmm?
You have to press the buttons.
Now we just put the sample, then we evacuate it. After evacuation, we turn on the HT, right?
Yes.
The HT stands for what?
high tension.
High tension.
High tension, like a power line.
It's just the old way they used to call it high voltage. you can see it's a pre-evac now, and it should go to evac, and then if it finally comes down, it'll be ready.
And we didn't have to
While
measure
we're-
the height because it wasn't.
It wasn't sticking out.
Yep.
I'm glad you remember, because I didn't. So, right now, while it's pumping, we can go ahead and capture the S&S image,
SMS.
so we have a map of where to look. We don't want that.
Is this the new example? Why the previous sample is okay, changed.
Okay, then do we have to change the height, or is it set to the last height, or what is it?
Well, right now, it's, we're down at
Yeah.
the camera position is as low as it will go.
Yeah.
So typically, you're going to be like at a Z of around 10 or 20,
Mhm.
but we could go to 20, just,
And we're currently
So we're
at
safe.
79, so
yes,
just set this to 20.
yes.
Okay. So remind me yesterday when we were doing the head. So we measured the head, it was like 27 millimeters. This was 79, so 27. Then we set this to 50 or something.
Yeah.
Okay.
That just gave us our maximum distance.
Okay.
Because,
Oh.
but it's probably easier just to click on the Z and enter, let's go to 20. So we'll be at working distance 20.
20 is working distance.
Yeah.
Yeah, we're setting
Unless we're
the
doing
stage
this.
to a Z position of 20, so our WD, where we want to focus the beam, is going to be close to 20.
Okay.
So we're right now, we're at 50.
Yeah.
So you can click on the green WD.
So Z is going to 20, right?
Yep, it's lifting the stage up.
Now it's
You
50.
can see the line, the sample, the whole, the indication of where the top of the
Oh,
hole
yeah.
is coming out. So we were really far away.
So if for some reason you ever touch you said the detector, or not the detector, but that part above you're pretty much replacing it.
There's a good chance it
Okay.
could damage it if it hits it hard.
Okay.
But if it, if you were just gently moving or something and it touched it, it would actually, the stage will stop as it senses ground, but a lot of times that's too late.
Okay. Okay, so then I want to hit WD.
Yeah, you could just go ahead and hit WD-20, double click it.
Yep.
And then, so we don't have a beam on or everything, but we've already pumped down, so we're close to the ready. And we're at
Okay.
a lower mag, so when we turn the beam on, hopefully we'll see something.
Okay, so turn the beam on.
Yes. Voila.
You see something.
I think at 20 we can go to a lower mag than if we were at 10. I think at 10, 30x is lowest.
So what is this one? You have to know. What
This is your titanium oxide.
This is titanium oxide.